Good afternoon, everybody. My name is Dangol, and I am here to present me and my group, Bajracharya, Suyog and Suyog, Khadka, the members of Group Syntax, are here to present about case study of the killer robot. So, to begin with the introduction, the case study of a killer robot is a fictional combination of articles, magazines, and newspapers, which is written by Richard G. Epstein. This article focuses on topics such as programmer psychology, waterfall model and prototype models, cyber computer ethics, cyber software engineering protocols. Also, this article starts with the manslaughter of a robot operator which works in cybernetics caused by the robot developed by Silicon company named Silicon Techtronics. The robot name was Robbie X3, which are developed for helping humans, but malfunctions of the code in the robot caused the death of the robot operator named Brad Matthews. The article begins by the prosecutions of Randy Samuels, who was the programmer of this robot. He was accused of falsely interpreting the code to him, which led to the tragedy death of Brad Matthews. This incident also shows the mistakes in programming, code testing, and bad management decisions that had led to the death of the robot operator. It teaches the lessons of ethics, responsibilities, and safety in computer software engineering. Next slide. The main characters present in these stories are here. Brad Matthews, as I said before, the worker, the robot operator who died due to the malfunctions of robot. Watterson was the CEO of Silicon Techtronics. He was the one who put Ray Johnson and Samuel in charge of the project. Cindy Yardley, she was the employee of Silicon Techtronics, who did software tests. She admitted at last in the story, she admitted the software test on Robbie X30 was faked by the company's heads, which in order to protect her co-workers. Ruth Witherspoon is an attorney or defended Randy Samuel, and says that the company which Randy Samuel worked for was responsible for the death of Brad Matthews. Martha was an anonymous newspaper source. She is the insider in Silicon Technology who gave Silicon Valley Central observation information about the group's dynamics on Robbie X30 robot project. She stated that there were difficulties in management, not familiar. Randy Samuels, as I said before, Randy Samuels was the one who was prosecuted for the manslaughter of Brad Matthews. He was the programmer who wrote the code causing the accident. Due to various pressure in the company, pressure from company heads who were overseeing the project, he misinterpreted the code. Sam Reynolds was a project manager who was insistent on using waterfall model. He even clashed with his employees and ended up firing her. Later on, we will discuss about her. Robbie X30 was the robot. Ray Johnson was a division chief who focused on success. He was determined for the robot to be successful. He even clashed heads with Sam Reynolds. Both didn't meet up. And Jane Anderson, like I said before, Jane Anderson was opposed of the waterfall model which was presented by Sam Reynolds. She even wanted to try other models like the prototype model. but she was ended up being fired by Sam Reynolds. And I'd like to call Supran.
So I'll be talking about who is responsible. At first glance, according to the story, it seems obvious that the programmer Sam Reynolds, Randy was accountable for the death of the robot operator. But it is not that simple, as in a huge team like this, responsibility is shared, not just individual, and mistakes don't happen in isolation. So the fault of the programmer was that he wrote the faulty code, he misinterpreted the code, and the mathematician of the team gave him the formula, but he misinterpreted it and provided he misinterpreted the formula, which led to the robot to malfunction. And another one who was responsible for it was the manager who pressurized Sam Reynolds gave him unrealistic deadlines and pushed him for rapid development, and he also pushed all the employees for finishing the project rather than complete it in a more ethical manner. He was also the one who also fired Jane, who advised him to use prototype model, but instead he forced Sam Reynolds to use the waterfall model. And the company is also to blame because they lacked chemistry, they had a weak safety culture, and there was no proper process in the coding of the robot. There was lack of testing, and there was no formal code review system, which led to the dangerous accident of Bart Matthews. And the last point is all the above layers that I just said combined, and I want to say that it's just not one person's fault. It is the combination of everybody in a team. Fault cannot be of only one person. It is of everyone involved. So the interface problem, why the operator couldn't react. So as you know, Bart Matthews was a robot operator. First of all, he wasn't that skilled enough, like he wasn't trained that much to become the robot operator. And also, they used an old IBM computer with only a keyboard, there was no mouse. And it was a very complex system, there was too many menus. He couldn't navigate faster, there was just one button that would navigate easier, but there was only a keyboard with no organization, no visual or audio alerts. So that led to a lot of errors in the system. Also I will point out the interface that they used violated Ben Snyderman's 8 golden rules of interface design. It is one of the most basic, fundamental rules of interface design, and the interface that they used violated the rule of Ben Snyderman. And most importantly, there was no quick way to abort or undo the actions when all went wrong. Bart couldn't quickly navigate the menus, which led to death of him. Now I would like to invite Suyog.
So good afternoon. Today I'm here to talk about how Killer Robot actually works. So Killer Robot works in 3 main steps. These are analyze, deciding, and taking action. So let's talk in brief in every step. So first step is analyze. So Killer Robot uses many cameras and sensors to see what's around it, and sensors are used in Killer Robot to detect the movement, to see the shape, size, and object. So for example, like in Killer Robot camera, it used to see the person's image or object image, and just like that, this sensor is used to detect the one of a human body, and then we have radar. Radar is also used in a killer robot. Radar has to detect the object while the environment is smoky, cloudy, or you can say like a darkness or foggy weather. All this information is collected by the killer robot, the computer system, to help to understand what is actually going on to the surrounding. So next step is deciding. So in deciding, everything is seen in the first thread, and then the killer robot actually collect every information from the first thread, and the robot has to decide what to do next. So here it comes the AI. So killer robot uses its own AI and its own specific programs to detect the target and to analyze and to finalize and to decide what to do next. So it checks whether what it saw earlier it was an enemy or a civilian or just a friend. So if it finds any suspicious things or it finds a target, then it decides whether it should attack or not. So before attacking, there are 3 levels of human control, and the first one is human in the loop, the second one is human on the loop, and the third one is human out of the loop. The first one loop means for the human must press the button before the robot attacks. That means here is a full control of human. If the human do not press any button, so then if human do not press any button, then no attacks will be proceeded by the robot. So in the second loop, it means the human on the loop. Human on the loop simply refers to the human acts mostly by itself. Even robot can do is and everything by its own, but human is still monitoring the every movement of the killer robots, like literally watching on the television, or you can say like a monitor on. So in this system, on the loop, in this loop, human can still stop the attack. If any something is wrongly identified the killer robot, the human can stop the attack. So on the third loop, we have is the human out of the loop. This loop is simply means for the time when robot do is and every single thing by own. It analyzes, it decides, and it takes action by its own. So here in this loop, human do not alert any human or control center or nothing else. Human out of the loop simply refers for it's actually made for the situation where no human existence is present. So now next one. So the third step is taking action. So taking action is simply means for proceeding the attack. If once killer robot decides to attack the target, then it uses its own weapons or tools to proceed the attack. So this can means like it can killer. So this means like killer robot use its own weapon, like firing the bullets or guns or launching the missiles or launching the bombs or do air strikes like flying the drones and other things. So in killer robots, motor, arms, and mechanical parts are also used to move and aim the target precisely during the attack. So the robot also can send the information to the control center by using its wireless system. So all of this, behind this all stress, there is a big powerful computer system. And there is a big powerful computer system, and this computer system actually use machine learning to get smarter over time by studying the past data. And the hardware like sensors and camera makes killer robot more reliable in different weather situation, conditions, and different battlefield areas. So even though it sounds so much advanced and so much perfect, but still till now killer robot is not a perfect tool for us. There are so many risks for us. Killer robot can make mistakes. For example, like if killer robot wrongly identify a target, if the civilian have a unclear image or data, then the killer robot might attack the innocent civilians too. And if something goes wrong with the killer robot, there is no any person who is take the responsibility. Like a government also can take the responsibility, a programmer can take the responsibility, even a soldier can take the responsibility. So just like that, in a killer robot, it also can be hacked. So which makes the killer robot so much dangerous, and it also got the malfunctions. So behind these all reasons, government and many countries are adding the safety rules regarding to the killer robot and adding the emergency stop button to prevent the accidents. So because of these all risks, there is a big global debate in the globally. Some says killer robot is a life-saving tool for us. It will help to decrease the number of dying soldiers in the war zone areas, but others says that it will be a harmful tool for us. It will literally destroy our human existence too. Because of this all reason, many UN countries and many other remaining countries too still are discussing regarding to the killer robot, whether it should be strictly controlled by every government or it should be strictly banned for everyone. So in short, killer robot works by 3 steps, that is analyze, decide and taking action, and it uses its own sensors, AIs and weapons to finalize the attack. So now I would like to invite my friend Suyog to finalize the.
So today I'm going to talk about the conclusion for the case of Suyog killer robot. The killer robot is not only the theoretical paper, it also teaches us that computing not only teaches us to make some apps or make apps, write code, or makes us system. It also teaches us that we should make an ethical thinking and we should make our decision with an ethical thinking and for the real world consequences. In the case that shows that computing is not just a technical but is also deeply an ethical choice. The death caused by Ruby CX30 was not just a program error, but it was also the main error of programmer, the test, and the final people who just didn't use the robot to finalize the project and just focus on the robot to just get released. And it was due to poor communication and pressure from the management and the people who also ignored warnings. It highlights the importance of responsibility in every stage of system development from designing to testing. Each character in the story shows different kind of ethical issues, such as Randy Samuels shows responsibility in the programming. If Randy Samuel looked the program carefully and didn't mistook the greater than sign than less than sign, then the issues would be less, and also the robot would be technically good and would help in for future aspect of humans. And secondly, Cindy, the honesty in testing. If she would be testing the robot with honesty and good, then nothing would like that would ever happen. Management. The second one is management from Reynolds and Johnson. They are the people who should have finalized the project and the testing process should be good under them. So moving on to the next slide. Ethics and professional conduct. Professional organizations such as BCS and ACM emphasizes should be on this kind of project, and they should also try on fixing their problems and check whether the robot is safe or not. They should work for public goods and safety, be honest and transparent in the world, and mainly avoiding harms through carefully testing and ethical decision making. The case reminded us that ethical standard protection should be both for user and professionals. Computers do what humans tell them to do, so the real responsibility lies within ourselves, not with the robots. And mainly it's not only the mistake of the robots, but also our programmers and also the users. So finally, I would like to say the computing is not only for coding or writing apps or making decisions, but we should make ethical decisions and also the real world decision on helping people. Thank you.
Spelling well mispronounced. Few months. Another thing was regarding your body language and the gesture that has to be maintained, because whenever you're giving presentation, your hands should be out of your pocket, right? And then you need to move your hand, not much, a bit, according to the point that you are going to address. Which all point that you need to give stress that have to be there. So you need to take in consideration about the time also. That thing has always to be there.